Thank you very much, and thanks for the invitation. I appreciate being here. Fantastic forum. And let's see what we can discuss today. I'll try to share with you some experiences from building a data sharing service for neuroscience. And let's look at what's in common across different disciplines of science, but maybe a few words about the brain first. It is, I must say to all of you, it is really fascinating to study the brain, because you're using the brain to study the brain, and it all becomes a little bit circular. This field has existed for a long time. I personally tend to think of it as, in a way, starting with Leonardo da Vinci or Andreas Vesalius, 16th century, with their fantastic drawings and interpretations. Very basic technology at that time, but extremely informative about the anatomy of the brain. But nowadays, it's becoming so complicated. So we are multi-omic, we are multi-scale, and does this really help? Do we understand the brain out of all of these different boxes? Well, we have at the bottom here, we have a whole brain scale. That means that the resolution in question here is maybe, let's say, centimeter level. What can you see, what can you measure with different instruments at a very gross level? And as we go up in this picture, we're getting down in resolution. Tissues, cells, tens of microns, down to subcellular resolution. One of these boxes here might be a bad picture of an electron microscopic picture, where you are at the nanometer scale. So at each of these levels, you have many methods, many types of data. In addition to that, making it even more complicated, we have time scales. There are events going on at picosecond level, very, very fast molecular level, up to the events that are just as relevant for the brain. Over years, the processes of aging. So what is the challenge? Most people are really, or most scientists in this field, are not really integrating all of this. Some are integrating a little bit across some levels, so they may start somewhere and they go a bit up and down along the scale. They ask questions, they perform hypothesis-driven research. But it's a little bit like, sometimes, the elephant and the blind man, for those of you who know that famous Buddhist painting. So the concept here is that we need to integrate as much as we can, at least. And then people will have to provide data, because it's going to be awfully difficult to read papers with interpretations and integrate on the basis of that. I usually call it good luck, have fun. And then you need somebody to look at these data, and usually we are, as scientists, on both sides. But traditionally, in many fields, it's a very one-to-one action, or few-to-few. Who's going to pay for that in the future? This is very expensive. So we need to do something about making the data more available, so that we can make progress faster and avoid misunderstandings in terms of the information being provided. So that's the data integration challenge. Let's just take a look at one level, complexity at one level as an example. So these are images from Timo Lickscheid, Katrin Amunds, and others at Jülich. And here we have brain regions, human brain regions, with different types of data illustrating what a region of the brain would look like, different things you can measure that illustrates one region's difference to another region. Different data types. And then to the right, connectivity, which is so unique in the brain, the fact that there is communication between these regions, and there are connectivity maps. So that's one example of complexity, one example at one level. For these reasons, because it's so much connected to location in the brain, everything we measure, we are a little bit like geographers. So in geography, you really rely on maps of the Earth. And in brain sciences, you rely on maps of the brain. And the difference is that we are completely relying on being three-dimensional. We have to be three-dimensional, and in principle, of course, four-dimensional, because the brain is also changing over time. There is development and other changes. Here are examples of brain atlases. To the left, from a rat brain atlas, which is built in our project, and to the right, from human brain. And these atlases are like frameworks where you can insert information. And that is one way, not the only way, but one way of integrating information. So basically, in the rest of the talk, I'm going to dissect this one. So for that reason, we'll bypass it fast. We'll just say that there's something on the left side, a lot of different things, that's being brought together in a knowledge graph, that's being stored in the cloud, that's been possible to work with for many. So we'll return to this one. But now a little bit background, one step back. Where do we come from in this endeavor? So we come from what is called the EU flagship project, Human Brain Project, which from the beginning had the clear intention to create an infrastructure for brain research. And it did so in different steps. So it first released 6 ICT platforms in 2016, covering different areas of investigation. I came in personally in around this time, 2017, and we then wanted to merge these ICT platform into a joint platform. But at that time we realized that this was a project. It did have a relatively long lifespan with renewals and so on, but it was really meaningless to build an infrastructure without having a long-term sustainability plan. So for that reason, we gave a name to the research infrastructure, EBRAINS. And then we followed the European pattern of trying to create some organization around it, which actually also led to being on the ESRI roadmap from last year. ESRI is the roadmap for infrastructures in Europe. And now we are creating nodes around in countries in Europe to use this infrastructure, to contribute to it, and maintain it and let it evolve in the future. So this is basically where we're coming from. We started and released the portal in the fall of 2019, and a lot has happened since then, and this portal is of course going to be completely renewed again now in a few months from now. So what is then EBRAINS? The definition is this one. It's a European distributed digital infrastructure for brain and brain-inspired research. So we say it is an open, state-of-the-art research infrastructure fostering collaborative brain science, providing tools and services that will assist the scientists in their research. This is very much centered on data. Data are collected with all these different instruments at all the levels we looked at. They can be analyzed, they need to be shared, and the aim is to integrate them. In the research in the field of neuroscience, modeling and simulation is really critical to try to improve the understanding of what is really happening in this structure. So we have organized this research infrastructure into these 6 main areas. At the top is the data knowledge, which is our solutions to facilitate the sharing of and the access to research data, computational models, and software. And then we have what we call atlases, which I briefly mentioned. These are the frameworks that allows us to navigate the brain and to characterize and analyze information on the basis of where it comes from. Then we have the simulation area, where we have all the model building tools and simulators, which is offered to the community, either as something you can take and use yourself or that you could work with online. We have brain-inspired technologies, which is neurorobotics, which is kind of a continuation of simulation into a more specialized area with embodiment. And neuromorphic computing, which is brain-inspired computing, building on the principles of how the brain functions. We have medical analytics, which are platforms that are covering key areas in clinical neuroscience research. The most recent addition to it is actually being released now. That is intracranial EEG database. Intracranial EEG, recordings made inside the brain in patients preparing for epilepsy surgery so that the surgery can be optimal for the individual patient. And these data are collected, organized, and managed at European level, which increases the likelihood of getting more out of it to the benefit of patients. Then we have the community services, which is basically a lot of things. Anything from the more social part of the community to also access to computing resources for different types of projects, HPC resources. So this is roughly what we have in EBRAINS. And then going to the top green circle, the data and knowledge services. So why do we bother about that? Well, tools and data, the way we see it, are drivers of science. The paradigms, the hypotheses, the questions are to a great degree influenced by what tools we have available and what data we have available. So the importance of being aware of and having access to high-quality analytical tools and data is very important. Then we have the open science trend. We are here now in the spirit of the open science trend, obviously. This is aiming to remove the barriers for sharing of any kind of output, resource, methods, tools at any stage, which is a very logical direction to go and very inspiring for us. Then we have something you can read about in leading journals. They pay a lot of attention to it. The replicability and reproducibility crisis. These words are used sometimes a little bit differently. I prefer to say that reproducible science, that means that you can look at someone's data and see if you get the same interpretations of these data, which you cannot do if you can't get access to the data. Replicability would mean that you need to know how someone did something so that you could try to repeat it and generate new data and see if that would give more or less the same result. And if somebody doesn't tell you how they did it properly, then you can't replicate. So these are key elements and very important for progress in science. And then, of course, the last point, the wish to contribute to the digital transformation in neuroscience. So then what is it we have in this service? We have something that facilitates sharing of and access to research data, computation models, and software. We have a service that delivers data consistency and quality by combining metadata ingestion pipelines. That means that you have data about the data, you need to bring those in, and you need to do that in an efficient and smart way, and we'll return to that. And add quality assurance processes. And another important point, this service provides clearly defined terms of use, responsible data compliance, data protection provisions, and governance mechanisms. The field of data governance is very, very important for all kinds of data in this area, and most other areas actually. And there's been a lot of investment from the Human Brain Project also in the data governance field, which we are now benefiting from. And we think also other fields may benefit from. Now, how? How do we do this? We have something called a knowledge graph at the center of this operation. That is a metadata management system. It's a little bit different from more classical ways of organizing data. So it's not a relational database as such, it's a so-called graph. It's an organized network of real-world entities with nodes, links, and labels. You connect all the elements. And the nice thing about it is that you can change it over time, and that is not particularly stressful. It's what you expect, which is not always the case with other types of databases where that can give rise to a lot of problems. So it's dynamic and flexible, and that is definitely what we need in order to move forwards in this field. And it's also very nice because we can look at it. And you can even look at it online live if you want to, if you go to our service. So here we are in this knowledge graph at the moment. And we can look around, and you won't understand much of what you're seeing here. But we do have something on top of this that allows you to read this information and get meaningful feedback, meaningful messages back again from the graph. Now, inside that graph, you can, in principle, put in anything. Easily, that can result in, garbage out. So in other words, we need to control the input somehow. Metadata are fine, and you can have a lot of free text, and you can have a lot of add-on information. But if you try to add a little bit of control on it, the value increases tremendously. That is why we have a metadata framework. We call it OpenMinds. It's a neuroscience-specific metadata standards and conventions for human, animal, simulated studies, models, software tools. Of course, shared on GitHub, evolving, changing. It has a core at this point in time. It has extensions. The core takes care of what's in common almost across any area of neuroscience. And the extensions go into different parts, and they are being added now. Needless to say, if this kind of work is done in splendid isolation, it will be splendidly useless. It has to be done in a completely international context. So we are working, for example, with the International Neuroinformatics Coordinating Facility and groups around the world to extend the OpenMinds framework. It's built into the knowledge graph, and we are using it when we do what we call curation. Curation is probably a different thing depending on where you're coming from. What is a curator? What is most important always with language is to explain properly what you mean. So for us, it's the following. It's a quality assurance process for the metadata, not necessarily for the data per se. The data are coming in from many, many sources where those who provide the data will have to be responsible for making sure that they make sense. But the curators can give advice on how you structure the data, making sure that others can interpret your hierarchy in the data and all the features. And there are certain standards you can even impose there, depending on the field. And then we use the OpenMinds metadata standard. So we thereby introduce an element of similarity across different types of data, making them more comparable. So this curation workflow, it starts from the left with an ethics and regulatory compliance check. If data are going to be shared in our system, we need to know something basic here, which is usually very easy because most scientists have full control of this. Then the data are structured in an understandable and consistent manner, and there may be some curation assistance on that, not much usually. And then comes the OpenMinds metadata. We provide also tools to those who provide data so that they can, and the best would be, start early on to think through at an early stage in the research, how would I like to structure my metadata? Because I'm not only aiming for my research paper and then goodbye. I'm aiming for my data to be available and to be meaningful in the future and for others to also look at. That's why we need this. They write a data descriptor, which would be quite comparable to what you find in a research article, but the data descriptor is really focused on the data. So it's a little bit at a distance from the research question. We recommend, or we always say, you have to indicate how can others use these data. For example, we say you have to tell others that they should cite the data. So a Creative Commons license is a very good thing to put on, so we recommend that. We don't think it is meaningful if you don't require that. And then you can put on other restrictions if that is a need. The next is the upload for long-term storage, where we have a centralized type of storage for this. And we're also working now to have storage in different locations where the metadata are curated, the metadata go into this knowledge graph, they will then be exposed to the world, and we can tell where the data are, which is also another approach. But we do have storage as well. And then finally a publication or publishing the data, if you like. Some people are telling me that sharing data doesn't sound so nice, publishing data sounds better. I don't know what you think. Yeah, so here we go. We then have on this axis a so-called level of fairness. Fair is, of course, findable, accessible, interoperable, and reusable. And then we have the amount of information you need to add in order to become fair. Now, it's becoming easier and easier because journals are requiring this, funders are requiring it, it's kind of becoming the norm. So some curation is needed in order to be a little bit fair. And the pieces in the puzzle are kind of thrown together and you see something. If you invest more, you can make the pieces in the puzzle really come together nicely. It takes a bit more time. That's when you have added more metadata, better descriptors and so on. Then the value goes up and the puzzle is easier for others to deal with. So, now, when we have a shared data service, we actually are using then the curation services. So the shared data models and software service is basically the curation services. When we have a find data service, finding data, models, or software, we are directly going into the knowledge graph. And then we are offering two ways to look at it. One is a graphical user interface, and this is open to everyone. No restrictions, no accounts, no login. And you can search. And you will see, this is already a bit outdated, you will see that there are nearly 1,900 contributors of data at this point in time. There's around a large number of data sets and so on. And you can use the faceted filter search, which is picking up the information in the graph, or free text, which is also picking up information, which will result in what we call data cards. This is a little bit restricted with regard to what it can show, but it's very convenient. It will give an overview of the data you found. You will be able to click at the descriptor, see how you get the data, and so on. And there will be methods and other metadata available in the card. Or if you want to see everything that's available for these data in the graph, you can request an EBRAINS account. There are 6,000 such users now around the world. And they can then go into a query builder and API and actually have this programmatic access where you can actually see everything. And I would like to emphasize that the query builder is actually very user-friendly. So this is clearly going in this direction. Now, how do we communicate with data providers about this service? Well, if we have a data provider that would like to make their data available, together with a journal publication, might be a very common situation, they will ask us, what can you offer? Well, we will then say that we can offer you a track for publishing research data alongside a journal article. We have a special track for journals publishing data descriptors. We have now built this into Spring in Nature, but it's open for any journal submissions. So those who come in this route, they choose how they want to do this, maybe share the data before publication, maybe release the data at a point in time when the paper is out, but we provide intermediate URLs allowing reviewers to look at the data as they evaluate the paper. Another example, someone might say that the data from my research is of a foundational nature. I worked a lot on this. This might be used for different things. And I also want to easily find back to my own data. I don't want to take the risk that somebody's leaving my lab and things are not as organized as they should be. If they're in this system, they're taken care of. Also, there could be people looking for research data to complement their own research. That is obviously what we really want to see, that these data are being used. And this is then when the curation, the value of the curation of metadata comes in, because since the metadata has an element of standardization, it is more easy to find things that are related. The discoverability increases, the opportunities for reuse and interpretation increases. We have, of course, a lot of data coming in through the Human Brain Project, which has played a key role in kicking off this. And we are now also receiving a number of other projects coming into the infrastructure with brain data. So here are 3 examples. As you can see here, one, for example, digital brain tumor data, a complete atlas being shared in the system, data on intracranial electrophysiological recordings, and other data types from animal models and gene expressions. And many very external type of data from our perspective, which we are very happy about the use of the system. Now, here's an important slide in all its simplicity. Access to data levels and conditions. I've so far not touched upon this topic, just assuming that you can bring data, you can reveal metadata, you can make it searchable, findable, and so on. That would in general be true for research data coming from animal experiments, provided, of course, that the ethics and permissions are in place. When you move into human data, it becomes more complicated. If the data are anonymized, but please note the definition. Anonymized, the simplest I can think of is to say anonymized to the level that no one, not even the researcher or those who provide the data, can find back to the individuals inside the data set. So if something is wrong inside the data collection and you want to correct it, you have to take it out and replace the whole thing. Then it is anonymized. If there is a little key in a box somewhere, it's not anonymized. If somebody can say, well, I have a code here, I can find out, then it's not anonymized. Then it is, in the GDPR terminology, pseudo-anonymized, pseudonymized. I think it's pretty close to the American de-identified. So, yeah. So here we are. Open access for anonymized, given the definition. And all animal data could be like that. Under embargo would just mean that they are open access, but they will be protected for a while until they're released. This is, in the human context, everything which is completely non-identifiable. Restricted access means that you can get access, but it's a little bit more layers to go through. You may have to be tracked, logged, you have to sign on to agreements and so on. This is something we adopt to strongly pseudonymize de-identified data given a number of conditions, so special cases. The general situation is that most data are either too raw, too risky in terms of identifiability, and you don't want to make them less identifiable because there are features inside that are really critical for the research. And lots of pseudonymous data fall into that category, and they need controlled access, and there will be a need for collaborations among infrastructures to do this in a smart way in the future. We don't want all the different infrastructures to develop their own solutions for this, because it's a very generic type of challenge. It must be solved, it's on the way, but if you ask me, are we happy today? No, we're not. And that's expensive, because it means we cannot use extremely valuable data across countries. No, very often not. How can we afford this? We have to solve it. So here's the logic for the EBRAINS. On the left side, incoming data model software, the curation step, building the metadata or entering the metadata in a knowledge graph. Maybe also connecting the metadata or the data sets to location in an atlas system, as we emphasized in the beginning of the talk. And then you can start using tools and workflows. So we have lots of tools and workflows. Yeah. A kind of detailed webcast on this is found a Nature webcast. If you search for making small data big, Nature webcasts, you'll find it. That gives a few details and a few perspectives from other people as well. There's a team that's been involved in building this at different locations in Europe. And they all contribute with very important parts of this system. And my comments, we might refer to them, would be a little bit, are we horizontal or vertical in our services? How much do we specialize? We think of ourselves as fairly horizontal, going across many fields of neuroscience. Are we sharing or publishing data? How should we, or perhaps think about comparing with journals? How much effort can we expect from data providers? Do we need a changing business model so that it's really seen as obligatory and important to spend just as much time on sharing data as it is on producing papers? Level of fairness, how far should we go? And will we have funding in the future for non-transparent basic science? Those were my thoughts. Thank you very much.
Well, thank you very much, Jan, for your keynote, which for me fits perfectly into the theme of evolving data science. And from your last issues that you raised, you're really in the evolution process. Now, we will not have questions now. We'll have a discussion later in this session. So I invite you, Jan, to take a chair while I call the panelists to the podium. And the first one I call up is Maiike van de Kamp. Please take a seat. Maiike is Deputy General Director at Naturalis, right here, the Biodiversity Center. She has a strong background in policy, management, and leadership. She has been mainly concerned with developing national and international cooperation between science, industry, government, and society. The next speaker is Niklas Blomberg at the European Bioinformatics Institute in England, part of EMBL. He is the current director of ELIXIR, ERIC, the European Life Science Infrastructure. Niklas has a background in computational chemistry, structural bioinformatics, and biomolecular science. And he also co-chairs eTransafe, major in Innovative Medicines Initiative project to develop open knowledge sources for drug discovery. And finally, I call to the stage Dieb, data scientist at the National Institute for Material Science in Japan. His research includes the use of machine learning, experimental design in material science, and he's also used a natural language processing approach to create a research topic map for the Samurai database in material science research, which we in fact heard yesterday. Thank you for that presentation yesterday. I would like to repeat now the questions and topics that we are discussing in this panel session. First question, how will data-driven research develop in the face of exponential growth of data sources in data silos? Second, what are remaining obstacles and inefficiencies preventing data-driven science from being more available for everyone in the R&D communities? Third, how do we need to organize the huge domain of digital objects in the evolving global integrated data space? And then, will fair digital objects help to improve data-driven research? And how can they play an important role in the urgent changes to come? Finally, what should policymakers do and what is expected from people working on the technology in relation to the policies? So that's quite a range. And maybe I'll start with Maiike. Can you make your statement in 5 minutes, and then the others will make a statement in 5 minutes. After that, we'll have the discussion. Please, Maiike.
Thank you. Welcome again at Naturalis. We are very happy to host you, not only because we thought we have to offer a nice venue. Sorry, it's very crowded, one of the busiest days of the year because it's autumn break. But also because we strongly believe that fair digital optics is really going to change and is already changing our biodiversity research in Naturalis and on a global scale. And please let me explain you why. Because 5 years ago, most of my time I spent on explaining people what is biodiversity and why is it important. I think nowadays, if you look into the newspaper and news sites every single day, we don't have to do that anymore. So people are very much aware of biodiversity, maybe not on a detailed level we would like them to, but people know about biodiversity and also have a much stronger sense of urgency to act. And that means that large economical sectors, such as the financial sector, construction companies, large-scale industry, is actually addressing us now, like, okay, if we want to do something about biodiversity, what then? What can we do now? So time is now, also for us as scientists. And on the other hand, when it comes to biodiversity, we only know about 15% of our biodiversity worldwide. So we have a serious problem also as scientists, not only as society. And even in countries like the Netherlands, we know our species, we know our biodiversity, but still then it happens right in front of us that 75% of our insects basically vanished over the past few years, and we didn't even notice until it happened. So our dream as Naturalis with our partners, our dream, our vision, our also scientific Man on the Moon project is to be able within a few years to basically real-time monitor biodiversity. So that means wherever you are, whether on the countryside, whether it's in the Himalaya or in Southeast Asia, you want to know right then on the spot, like what is the status of biodiversity, the ecosystems, and what can I do to act? That is a huge endeavor, and it requires a lot of application of many techniques. So we have invested a lot already in the past on genetic technologies, artificial intelligence, 3D, imaging, and every technique which basically helps us to identify species and monitor species. So in that sense, we have already started to build digital objects, and we are expanding, and we seriously need to take that to the next level. So that again, everywhere, whenever you are in the next 5 years, you are able, whether you are a government, a company, or a citizen, to contribute to preventing even further climate change and biodiversity crisis. Thank you.
Thank you, Niklas.
So thanks a lot to Koenraad, to Peter, and the organizing committee. It's really nice to be here. I'd like to share a few thoughts from our experience in ELIXIR and how we approach FAIR. And so I'd like to start with arguing, actually, ladies and gentlemen, that we need data silos. In fact, I think we need a lot more data silos to manage the challenges of scientific data. And I realize I might need to qualify this, but if we think about what is a silo, so a silo is a very carefully controlled and curated environment for storing valuable grain for a very long time. And actually, if you control humidity, you can store for decades. So I think that's a perfect analogy for what we need from data. And I think, Jan, you showed that, what a carefully curated community silo of data can really accomplish. It drives careful annotation, it drives careful curation of the data. And I think, essentially, I think what we need to do when we start to think about the FAIR journey and the challenges of scientific data is that we need to make sure that we carefully control the grain before we start to make the muesli. So and I say this, so one of the things that we've done in ELIXIR over the last couple of years, we have, like many other, been engulfed in the pandemic, done a lot of work on viral genomes. One of the things that we've driven through ELIXIR is what we call the European COVID-19 data portal. And I think one of the, and there are some posters upstairs with how we've used RO Crate and Workflow Hub and Galaxy and so on to do this. But one of the really strong learnings, I think, from that effort, which is really like Jan's effort, an attempt to provide scientific data in the context of other scientific knowledge, is the stronger the underlying community database, the stronger the community standards and annotations are, the easier it is to make the data sources interoperate and actually provide that richness and the context. And that's really, I think, the core argument here is that for us to drive interdisciplinary research and value out of the open data resources, we need to start to invest or make sure that we invest in the community data resources. Now, I think that there are some really important differences between, say, a grain of wheat and a grain of truth, I guess. I mean, you can open the tap on a data silo without actually emptying the vessel. So I think that's the argument for open data in the first place. But I think the real one is that when we start to separate the wheat from the chaff, sort of metaphorically in the science, then really we want to understand how people have done that dechaffing. We need to understand the provenance, the transformations, the workflows. How did you arrive at the end result? And I think that brings us here. That's where I think we have the real added value of the FAIR digital objects. If we look at the posters, the work that Stian and others have done around RO Crate, it is really about encapsulating that, dechaffing the provenance of the data. And I think that's a really important role for the fair digital objects, and I hope that's something we're going to explore in the discussion this afternoon. So I guess that's the summary of my intervention. I think we need to recognize the incredibly important role of the community standards, the strong community databases as the sort of primary silos, the storage rooms for the data, and then really think about how we do the transformation journey when we make the muesli later, so that we actually understand what's been going on.
Thanks for your beautiful metaphors. Sai, what are your ideas?
Okay, so hello everybody. So I'm a data scientist working on materials informatics domain. So probably my thoughts would be within this domain. Thank you again for inviting me. It's nice to be here again on this stage. I was here yesterday. So in materials informatics, I think material scientists started to realize actually how data-driven research can support materials research. We have actually find new materials that took usually 20 years for development in few months. So we realize how important to use this data and high quality data to support materials research. And even further, if this data is fair data, I mean, it will be more valuable because it can be collected more efficiently and managed and then used to analyze and support material research. So in NIMS, in the National Institute for Material Science, we have invested in building some platform trying to support the material science research. And recently we started to move to fair data. But to be honest with you, we have the willingness to do so. We realize the importance, but we lack the experience of doing so. We lack the tools, the necessary tools doing so. Considering that there is a high level of domain knowledge for material science, there are so many varieties of materials, biomaterials, there is magnetic materials, thermoelectric materials. So each one has its own like features and domain knowledge. So how can we combine this domain knowledge with fair principles? I would say one way to go is like to have a fair materials data, like fair materials data group that can specifically work on materials data collection or like building infrastructure, fair infrastructure. The second point I'd like to point out is in many data, there are some well-structured data or half-structured data, but also there is the non-structured data like research papers, and they contain usually useful insight to support materials research. So in that case, and as I presented yesterday, I work on natural language processing to be able to collect these data. So this, I would say also, like natural language processing can be helpful to support any potential infrastructure, a fair infrastructure for materials data. That's my thought probably, and thank you.
Well, thank you.
We'll discuss later.
Yeah, thank you for pointing out indeed that, we're not talking about, just objects, but also loads of unstructured data in which we have to find a way. So before we open up to a wider discussion, let me just ask, do we have any immediate reactions to each other's statements, including, of course, to Jan's presentation? Please. Floor is open to yours. Niklas?
Well, I think the example from material science, I mean, you brought up training and the need for developing the skills in the community. I think that's perhaps something that's very easily forgotten, but it's really a big challenge, I think. We need to reach out to the young scientists, the students, and the budgeting scientists, and really help them when they're setting up in their first research group or when they're starting out on their doctoral thesis, to make sure that they have the training and the tools available to do it right from the beginning. And I think for us as a community, providing both the materials and getting the time to act as trainers is going to be is a big challenge and something we need to raise with policymakers.
Yeah.
I think that's a really very important point. We are emphasizing training a lot. I could have mentioned it here as well. I didn't. But producing material, course material, delivering on the web, delivering through workshops and schools and so on, summer schools, whatever you have. We're placing a lot of emphasis on that. And I agree with you, it is tremendously important. We also would like to see the different societies. Like in our field, for example, we have Federation of European Neuroscience Society, you have SFN, and so on. We think that we need to get them more involved in this as well.
You all think, I mean, I've heard several times here, you have your expert communities, you have to develop these expert communities. There's not necessarily anything wrong with silos in which you sort of, concentrate on a specific domain, specific data types, etc. But do we then also risk sort of going into directions where we in each silo reinvent the wheel? How can we sort of have wider cooperation? How can we sort of leverage our knowledge in each of these silos to get a step further?
Well, I belong to those who believe that there is a lot in common across disciplines and fields when it comes to what you need in order to, let's say, share data, organize data, manage data. There's a lot in common, I think. So, therefore, it is important not only just to make sure you are managing the data and you are building something, but you also share how you do it. And the architecture and the underlying principles should be transparent, and I think they are in general, so hopefully this is going in a good direction. I'd also like to say that I think silos are fine, but this typically illustrates the point that the word, like silo, can be looked at from many different angles. And I agree with your angle. There is a lot of positive to it as well. But of course, if it is a closed silo and people are only staying inside the silo, for the brain, for example, then you probably wouldn't contribute too much to understanding the brain.
Yes, Maiike.
So I think our strategy for the last few years was stressing and focusing on that societal question or even bigger scientific question to see, because we need data scientists. We can't even do our research anymore without them. And we certainly need much more multidisciplinary research than we do now. So we are trying to approach it constantly from that question. And we also see, especially with the younger generations, that it works pretty well. Young students, PhD students, because they really get inspired also, whether it's data science or chemical science, even mathematics, to work on these bigger life-threatening questions at the moment.
Yes.
Please.
Yeah. Okay.
So I was thinking that also, like from different perspective, if we did not go to other domains and see what they need really, then how can we validate the usefulness of fair data? And probably, at the top of my head, like there can be an upper layer that is domain specific to other like layers that are like essential fair data, and then one additional one that handles the needs for specific domains.
Niklas, did you have a final comment?
Well, so I think one have to accept a fair amount of reinvention of wheels. I mean, the wheel is a good example.
A fair amount, you said, right?
Yeah. Yeah. I mean, the wheel is a good example in itself, isn't it? It's been invented by very many different human cultures independently, and yet when we put them on cars today, they have a rather limited number of standard sizes, and it actually works. So I think there is an overhead in trying to harmonize communities, and I think the judgment, and that's really the judgment of communities as those on this conference with the technology providers, is when you move from that inventive sort of reinvention or finding solutions that just work into something which is scalable and can be provided at a much larger scale. And I mean, Jan brought up access to controlled data or sensitive data. That's probably one of these problems where it's now coming into a domain where we can't have domain-specific solutions. We need to find harmonized approaches. There are many other fields of data science where I think reinvention of wheels is probably okay, because actually we want a diversity of solutions to come forward, and then in conferences like this, look at the practical implementations, look where they are working, and then try to move forward as a community.
Okay, thank you very much. I think it's about time to open up the discussion, and please challenge our speakers and come with your ideas, and of course, parents, yes. There is a mic.
Yeah, so Jan already made my point about the silos, because I remember when in the European data spaces, where actually in the AI coalition they were called silos,
yeah,
people jumped and say, because to them silos means by definition non-interoperable, you know. So when you qualified it, totally in agreement, but we have to be careful Maybe because I'm wordsmithing all day on the declaration, I'm really hypersensitive to small meaning differences. But anyway, so that is very important. I would like to focus a little bit on the quality. So I love your work, of course. I think that whenever you talk about fair, there's lots of people saying, but it doesn't say anything about quality in the principles. That was, as you remember, Niklas, a deliberate choice. You can make complete fake data fair. In fact, we did it recently in talk, where we made fake data to show that the technology worked, as long as the metadata say, this is, by the way, synthetic data, it doesn't relate to real patients, that's fine. So I always maintain, I would like your reaction, when people attack me on this quality thing, say, you know, quality, first of all, is in the eye of the beholder. You know, step counters are lousy data, but we did some pretty interesting things with them. So provenance, as you said, is probably more important than the quality as such. Of course, you need the best quality you can get, but the provenance, who said this is not true, with ORCID, annotating triples in the graph, those kind of things, provenance to me is a much more important element of the FAIR and interoperability, because machines, as we know, are totally unable or almost unable to deal with near sameness. That's our focus of research at the moment, how to teach them to say, hey, this is almost the same. Acting human, acting mouse, for example, is almost the same without being explicitly instructed. So can you react a little bit on the balance between quality as a sort of also vague term and the importance of rich provenance, which is a strong part of the R principles, the R set principles?
Who would like to take this up?
I can try. Well,
Yes, Jan.
I like this angle of view. It's very important, and as I also indicated, we do not go into data sets, our curation team do not go into data sets and say that we don't like the way you tuned your microscope that day. We can't do that. It's their field, it's their domain, so we work on the metadata. I completely agree that the provenance is super critical. This quality aspect is fascinating. One thing we discovered is that when you meet enthusiasts, those who really see the value of this, and they say, hey, can I really share this collection? What the best people do is that they say, now I realize the mistakes, the things that doesn't look that good. What is that? Well, you could say, oh, it's lower quality. But turn it around. You make a great collection of data available, which may have these mistakes, but that's the real life, and they can be reused, and you can find a lot more information in them. So one needs to be extremely cautious with words like quality. You simply have to explain what you're talking about and be concrete. That's my take on it.
Maiike, I saw you nod.
Yeah, because I think if you focus on it too much, it will hold us back a lot, as already did in the past. But yeah, totally agree.
So I think that's a really important role for these core community data resources, is to look at what is quality. I mean, quality is always defined in relationship to use and the value. So what is high quality data set for one application might be completely insufficient for another. But I tend to think about PDB, so part of my background is in structural bioinformatics. In the 90s, there was a lot of challenges with because there was a rapid technology development, so many groups were publishing data sets very rapidly. Some of them were plain wrong, some of them used the methods incorrectly. There are assumptions that goes into calculations that didn't bear out, and so on. And so the community as such went through quite a bit of soul searching to essentially, Rob is smiling, I think you were part of that soul searching exercise in your postdoc, weren't you? But I think the part of that is really the strength of communities to define what they see as an acceptable level of science that needs to be published and propagated. And some of these data sets were plain wrong. There was a lot of discussions in 95, 96. If you now look at the processes, they've settled. This is not an argument anymore. And there's been 20 years of high quality data coming out with a sort of a minimal community acceptance. The other thing that went through was a sort of accepted set of metrics, criteria, and quality assertion processes that came alongside with the data. So I think there is again an argument for rooting activities in the scientific communities that understand the value, and an element of letting the flowers bloom, and then eventually some of them will be successful. Because in this case, there was very high reuse value for those data sets.
Sai, do you have any comments on provenance and quality?
Okay, so we also thought about this, like how to ensure quality, because materials data quality is also very important. But what we did back then is that we connect any data set contributed to the contributor himself. And then in that way, people can check who contributed this data. Of course, this is not guaranteed that this data is high quality, but at least like community can check who contributed, and then probably if they trust or if they think that high quality data, they can use it. Yeah. But we won't be able to find like a proper solution to ensure quality.
But you seem to agree that with Barend that provenance is an important aspect of quality.
Of course.
Questions, please, comments? Yes. Yeah, microphone is on its way.
I wanted to bring together a potential avenue of collaboration with a lot of what you're saying. I like that idea of the brain atlas as a way of having some spatial extent that you can then put things into. I know in materials world there's a similar thing, not for materials in general, but for like materials devices, there's a possibility of like what's happening in this region. And there's also a parallel with multimodal and multi-scale in terms of space and time dimensions, but also modalities. There's multiple omics, but there are multiple material properties that exhibit. And the other thing with the atlas connecting with what you said is how does Google Maps and Waze directions work? They have very simple sensors, just GPS, but they're able to plan people's pattern routes and traffic because there's a firm atlas that Google got with satellite images, but knowing the road infrastructure and having that atlas to map on limited sensory data. So just given that sense, and given with multimodal and multiscalar, there are only 7 MKS units, right, in the international system. There's like length, there's time, there's certain things that are very common across domains. So I'm wondering if there's any fruitfulness there, minding that the benefits of Cambrian explosion of diversity, but aligning at this level in terms of coordinating cross-disciplinary, if there's been any thoughts of that.
Any panel comments? Yeah, you want to start?
Cross-disciplinarity, I'll be a little bit cautious, but just when you come with this comment, in the context of brain atlases and taking care of lots of different data and aligning them, registering them to atlases and so on, this is also very relevant for modeling simulation parts where you can build. We have something called a virtual brain, for example, which is also included in EBRAINS, where you can have a scaffold with quite principal information, fairly basic level, and it can be gradually expanded with more and more detail over time. Just as a comment I felt was a little bit speaking to what you mentioned. But I think these reference frameworks are tremendously important, and geography and Google Maps are the super good examples.
Niklas.
So if I think of the work that we've done in the COVID portal, when it comes to interdisciplinarity, so one of the efforts is to cross-map social science data archives with the life science data archives and try to find commonalities. I mean, the types of variables that you are talking about are often very easy to crosswalk, and you can do that quickly in an Excel spreadsheet. They might have different names, but the concepts are the same. I think the real challenge is when you work and try to index across disciplines is for the concept that what Barend called near sameness, but where you need to build assumptions into the crosswalk. And so are these two things equivalent? Because that equivalence is often sort of very dependent on the scientific question or the projection of the data that you're choosing. So I think that's the much bigger challenge, and that's the sort of fruitful ground for interdisciplinary conversation. And I think that's not a fixed, immutable mapping. That is very much a sort of a scientific question-dependent mapping. And I think Carol, you and Paul Groth worked on this many years ago, what you called scientific lenses, which was really about how do you deal with that interdisciplinary mapping. So I think that's the interesting part. The sort of author is often very easy to crosswalk. Mm-hmm. Some other things are very, very hard.
Carol just raised her hand, right? Yeah, microphone is on its way.
Actually, I had a different question. So the presentation was marvelous, and I've worked in ELIXIR for longer even than Niklas, which is remarkable. But the kind of assumption is that this is heroic infrastructures, which are fully with significant resources associated with them. But actually, the majority of science is long tail science. It's small groups. Small groups on small projects, actually generating data where those PhDs and postdocs will disappear. Lots and lots of data. We have hundreds of databases in ELIXIR. Some of them at the national level, but most are investigator or specialized resources. So it's actually a huge mosaic of complex interaction of often short-term funded resources. So how do we then square this? The kind of request that we're being asked here to make everything fair, to make everything into integrated knowledge graphs and so on, with this world of actually in the small, in order to be able to create the bigger the knowledge graphs that we talked about.
I'm sure you all have great answers to that.
I can make a start.
Niklas.
I think so. I agree. I think it's a really difficult one. So one thing that we've tried to do in ELIXIR is to help ourselves, but also help funders and policymakers to separate what is research infrastructure from what is actually research projects. So many of these small, wonderful research databases are really investigator-led long-term research projects. And so sustainability might be a challenge, but it's the same sustainability challenge as any long-term research, investigator-led research sort of program, whether or not it comes out a database or just a body of knowledge. That doesn't make it easier, but I'll come back to what I think how we have to deal with those. The other are these really sort of much bigger investments which are there for the community. They're not investigator-led. They are, in some sense, needs to be governed by the community. We talked about PDB, the Protein Data Bank, and protein structures. I think this is one of these. It's not led by investigators. It's an appointed investigators, but actually, if you look at it, the PI has changed many times, but the institutions have kept the data resource going. And there are mechanisms for community development. And there, I think we need to work with funders in a much more strategic way. But I think they also, for that, you call it long tail, I don't like the expression of the long tail, but I think what that really argues for is very standardized and lightweight methodologies that work sort of off the shelf, because it's inconceivable that we can train all these people in complex specialized tooling or complex specialized standards. And I think there's another really important argument for that, to use, say, standard web technologies. And that is because the PhD students coming out of those groups might not stay in academic science. By actually using industry standard tooling, industry standard, say, HTTP type exchange protocols, we also equip them with transferable skills for their future careers. So I think there are several arguments for go very lightweight to help with that community.
Do we all agree on that? Jan?
I think this is a highly interesting question, and we would need another conference to go through this, because, for example, the EBRAINS and what Carol referred to are two very different examples of how to do things. And I think one can probably learn a lot by looking at both of them. And my first association when hearing about many small databases is that we are seeing some coming into our system because they think it's a home. I'm thinking in general that data over time, storing data over time should be possible, but maybe not really actionable data, but they can be in storage and it's possible to get to them. And then if they are used, then there's new funding to make them actionable again. So that, I think there must be a way to deal with. I'm pretty confident that the different infrastructures we have will find a way of dealing with that. Yeah. And then if we can find some common ground on how to deal with metadata, we may find solutions here.
Maiike, you're a policy person, sort of. Do you have any take on that?
Yeah, so I think it's conditional. We have huge scientific and data challenge, but I think it also comes down to a huge challenge in leadership. So we are building these infrastructures also when it comes to biodiversity data on national scale, European scale. And when we just started the idea and thinking about it, we of course made huge tours throughout the Netherlands asking all top-level scientists what they actually need. And it was, to me, as a non-scientist, very surprising that we came up with having small databases and everybody was still convinced. And it was only just like a few years ago, and this was the future. And I didn't need any bigger or... So I think the whole transition, the acceptance and the vision behind it, training our new leaders, if you talk about PhD students, postdocs now, they are the future leaders when it comes to, I think, fair digital objects. And we also need to have a strategy on that, how to train. And also like having this forum as such. So focusing and searching for leaders on national scale and European scale and even beyond, that is really highly needed, I think.
Thank you. There was a question here from Mahmoud.
Yeah, sorry. So my question is about the completability, future completability and backward completability for the standards. In searching for a standard that works across all types of data, we face a danger of some of the assets that need to be recorded now. For example, endangered species or endangered ecological sites. And we need to work with the standards that exist nowadays. So is there anything that we can do to just reduce the chance of obsolescence of these data when eventually in the future we reach some sort of standard that goes across the board? And similarly, what can we do to try to build such a standard that maybe newer versions of this standard would be able to go back and collect the data and transform it to the newer versions?
Any reactions? Yeah.
Well, yeah. This is another conference, isn't it? And the nice thing about standards is that there are so many of them. And
yeah, let's make another one, right?
Exactly. Yeah. I want my own. So there are different initiatives around in trying to establish standards and set up some rules for standards so that you can't just use the word entirely uncontrolled, right? We have one in the INCF as an example in that regard. Well, I think we all subscribe to the idea that do your research, do it as good as you can, use the metadata models or whatever you have, and move on. We already started migrating because of these things. The only thing that will determine how much we'll continue to migrate in the future is funding and the importance of the data and the reuse of the data. And that will go on forever. So I don't think your problem is solvable. It's built into the science. And we'll find smart solutions as we go forwards. I don't think you can do it upfront and have a waterfall approach to this and say, well, just wait 5 more years and we'll solve it. I don't think so.
Is that a good answer? Okay. Any more questions? We have another 15 minutes for questions and comments. Yes, there we go. And then later, yeah.
My question is, who do you think is really responsible in making the data fair? Because we say we want the data to be fair, we need the data to be fair. There are researchers who generate and use it. They rely on the funding agencies to keep the science going. And then we are somewhere in the middle making the tools, policies that will enable the researchers to do it. But who is truly responsible? And if we say all, then we don't know who's responsible for what part. But for me, it would be nice to have another seat here to say there's a funding agency who sees the problem. Like I can get money for my PhD, but I can't buy a laptop. How do I invest money in RDM, let alone make it fair? So do you think we are doing enough and in the right direction? And who is in the end responsible for it? Or what parts of it are responsible for whom? Thank you.
Nice question. So, Niklas?
So I think there is a shared responsibility. This is not a cop-out. This is this is about thinking of the role of the different actors in the system. And so we've done some work, say, with ERC. So ERC provide guidance to the grantees on research data management. And so they are very clear. When you get an ERC grant, they expect open research data. They also expect a certain amount of quality annotation around that research data, and that's documented in guidelines to their grantees. And so as ELIXIR, we've worked with ERC to try to make those guidelines as helpful as possible. So I think that there it's very clear there is a responsibility for the researcher who is an awardee. He or she gets a pot of money to do a specific research project, and as a funder, they of course are entitled to put conditions on that funding. But I think with that sort of requirements calls also an obligation to try to train and support the individuals who are the recipients to give them guidance. Now there is a third role here that we haven't talked about, and so which neither the researcher nor the ERC as a basic bottom-up funding agency do, and that is providing the infrastructure that makes that possible. So ERC banks on other actors in the system to provide the data archives where that data actually can be made fair and made available, which is okay if there is a policy that sets that role for another actor in the system. I think that's one of the big gaps right now. I think another big gap in the system is actually the expectations on the institutions. So open data, the value of open data isn't accrued on the individual scientist. It's not the data set that you provided, say, Jan, into EBRAINS that really makes the system work. It's the collective amount of data that provide context, and that's what allows advanced analytics and artificial intelligence. And that, if we think about it from that sense, I think we need to look at the role of institutions, like universities, research institutes, to think about how is the data that they produce being reused by the community. And actually, I think at the point where you start to ask the deans of research of a university of how much data was actually published from your university as open data, where was that shared, and how was that reused? At that point, the incentive structures for individual researchers to share data will look very, very different, because they will start to ask this once a year. So I think there is a shared responsibility. I think one of the problems in the system is that we haven't actually articulated that responsibility for the different actors.
But when we think of roles, can we also ask the institution, for example, to create positions for data stewards, so as not to put the entire burden on the persons providing the data, but actually to facilitate the connection between the researcher and the data repository? Would that be part of an answer?
Or no.
Can you repeat this?
Yeah. Maybe the data stewards present in this room can give a yes or no, because I am not one, but maybe I still feel that there's a mandate missing. If I am in the role of a data steward, I can ask a researcher, hey, can you please do this? But no one's forcing the researcher. I mean, between publishing, postdoc applications, yeah, I don't have time to make my data fair, sorry. So it won't happen.
Yep, reaction here. Microphone's coming.
Sorry. So I'm a chemist, what I'm now hearing is the story of the lab safety officer saying, I don't have time to prevent fires, I have to extinguish them. And I really think for data management, which I think is an important part of fair, you're doing fair data management, you do that not only for others, you do that at the beginning of your project, and your own project benefits from it. If you delay it till the end, that's a waste of your time.
Sure. Okay, thank you.
Now that the microphone passes,
sure.
I cannot, of course, resist. So that's why I hate the term data management. It's like we have data stewards, and when we said in the high-level expert report for the EOSC, we said we need 500,000 of them. It's a new profession. And that was based on the idea that for every 20 data spitters, we need a professional data steward. Don't train all your scientists as a data steward, it would be a waste. I did enough programming during my biology study to know I would never do it, but I had deep respect for people who can make even a Python script. So I think that the role of the data steward and a professional data steward with a 10-year track, that's another wrong term, a permanent position and a highly respected person of the research group, any modern research group, especially on big data, and not support personnel where I go when it's too late.
But then, is it the institution that has responsibility for creating
the
those
funder as well.
data?
So
the funders
the paper I published on it's irresponsible to pay for research without a good data stewardship plan. It's a waste of money. 85% of the data is not reusable at the moment. Let's not forget it. Tens of billions lost on record every year. So billions in the public sector in Europe alone, on record. So the funders have the responsibility to allow data stewardship as eligible cost And the institutions have the responsibility to keep data stewards as part and parcel of their research group, and it should be in the future impossible to get good research proposals rewarded unless you have that. That's the only way to go.
Thanks.
And that is that's critical to make this happen.
Baron, can you pass the microphone to behind you?
Yes, Ben Schaap, Wageningen University. At our university, we have problems creating career perspectives for data stewards. They're now sort of researchers who get a role, and I would like to ask the panelists if they have career perspectives for data stewards.
Good question. Yeah.
Well, first of all, we have a team of data stewards, and we'll pick up the word, and there's a lot to learn regarding terminologies. I would say that they are very competent. I think I can say they really enjoy this because it's like going into a new terrain and really contributing to a change. So I'm very positive to it. We're seeing lots of good careers coming out of it. They are not. So this would be like when we had IT in the 80s, an empty space. There would be a person here or there, right? And then they came, and now we have all the IT personnel. Of course, we will have this type of personnel in the future. One way or the other, there's no other way.
Great. Wouter now. And then behind.
With my question, I would like to return to the issue of provenance, but in relation to transparency and accountability. Most people think that data are very simple things, as you have measured or observed, but data in reality, they are raw data are processed, they are combined, they come in a model that results in new data, they are combined again with other things in a model, and you want to trace that back. And that is important for transparency. For example, in climate research or climate change research, there are a lot of these kind of recombinations, and etc. And that must be transparent. Otherwise, you will have climate deniers who will look for everything, and there is a problem. So I think that also the fair digital objects should also, in this complicated sequence of data that are processed in totally different ways, coming from different domains and different systems, that it works. It is also political accountability. So the question is to Jan, because you are working also in a complex system, you probably have less problems with research deniers compared to climate scientists, but how do you deal with this issue what I'm mentioning?
Good question. It is not an easy one. I think if your main point is the provenance and the tracking of all information, I don't have any other answer than looking at different ways of doing it and learning from how the effect it has. We do have different schools and different directions also in our field, but I'm not seeing the type of, let's say, problem that you are pointing to from your discipline, fortunately not.
We have a final question.
Oh, final question. All right, thanks very much. I'm Carsten, I'm the German Climate Computing Center. But it's not about climate, it's rather, so actually here we're talking about a new design of a global data space. So I'd like to raise a question of global diversity. At the conference here, it's rather Northern Hemisphere centric, I would say. The data reusers would probably be global. I would assume that the Northern Hemisphere, as it's being here, are the data the producers, actually I would say, and then the reusers would be globally. So actually, how would you integrate everybody into designing and actually applying and accepting this new global data space?
Niklas?
So I mean, it's a really, really good question. There is no easy answer. This will have to go alongside capacity building. It has to go alongside training. It has to go alongside sort of a willingness to build up expertise also in low and middle income countries. But actually the only study I'm aware of is on biodiversity type genomic data from one of the German centers. And it's quite surprising actually, and it turns out that there is roughly as much sort of reuse of that genomic biodiversity digital sequence information data from low and middle income countries as there is being put into the system. So there isn't actually a massive global disparity. Also the The research volume is, of course, much lower in these countries compared to, say, Western Europe or the US. But actually, in terms of reuse and engagement with the system, there isn't a massive difference. So, but that's the only study on this I'm aware of.
It's interesting to know.
Yeah.
I think we have to stop here. So we thank all the speakers, and there's a coffee break waiting for you.